Hey everyone, welcome back to CodeBook. So today we are solving a very popular interview question, that is move zeros. So the problem is simple. You are given an array and you just need to move all the zeros at the end without changing the order of any non-zero elements. You have given an array and you just move to the end, all the zeros to the end. So we can do it by first instinct. What we can do that we make a two arrays. We are at first when we are at a 0, we can add 0 to the one array, and if we are at non-zero element, then we can add that in another array. So we will add all the zeros in one array and all non-zeros at another one, and then we shift these array to the end of this and we can add up. But the problem is we have given that you must do this in one place without making a copy of the array, because here time complexity, because we are using space, so here is space complexity required. That's why we don't need to use the extra space. We can move to the optimal approach. So now let's see how we can do this. So you have given an array. Let's solve it in the best way using the two pointer. If you know how can we approach the two pointer by swapping, then it will easy for you to solve this. So idea is use a two pointer. Let's say first I am at this array. This is my left pointer, let's say, and now this is 0. Then I'm moving my index, the index which is passes through all the arrays, that is, let's say this is the R index. I'm saying this is a 1, this is a non-zero elements, so I will swap these. I will swap these two because I want all non-zero before the zeros. So I will swap this. Here we can move 1 and here it is 0. Again, I'll move my both the pointers. Now because this is non-zero, so left pointer also move to next one, and R is here. Now here it is 0, here is also 0. Let's move the R. We have to stop at 0. Left will be stop at 0. Now 3 is a non-zero element, so we can swap this with this left pointer because we are at 0. Swap this. So here it is 3 and here it is 0. Now next, okay, let's move this too because it is non-zero now. Left is here and right is here. Now again, right is at non-zero, that's why shift these. Here it is 12 and here it is. Now you can see that our array changes to like this: 1, 3, 12, 0 and 0. This is the output what we want from this technique. Here time complexity big of 1, linear because we are going through the one pass, and second space complexity is also big of, we are not using any memory, that's why. So let's code this. First take a left pointer which is at 0, and obviously we are taking an integer, but I'm taking the variable as R because consider it as a right pointer. So if nums of I is not equal to 0, then what is the condition? We have to, if it is not equal to 0, that is we are at non-zero element, we will swap at this. Swap the num of, I'm sorry, I, it's not I, it's R. L with nums of R. We start at, this is the position for non-zero. So now let's swap here in the temporary variable for swapping. I hope you know this. Sorry. Okay, we will swap and then we move our left pointer. So this is how we can do this. Okay, so it passes all the test cases. So there is a quick idea. If there is 0, skip. If it is non-zero, then swap. This is the idea. We are not using extra space. We are maintaining the order and solving in a single pass. So if you found this helpful, guys, don't forget to like, subscribe for more coding interview questions, and comment which problem you want next. Take care and bye-bye.